Right, time to get into sample 16.7 here. We're going to learn how to calculate hydrogen ion concentration based on a pOH. So there's going to be a multiple step process. Um, you look at this first question, our sample is we have apple juice, has a pOH of 10.24, find hydrogen. That's our first step. Analyze, read the question, make sure you know what you're looking for, what you have, what you need. Well, the plan of action, second stage here, is to consider the process you'll take or the steps you'll take to get there. So if we begin with a pOH value, pOH, the easiest method is to go ahead and use the relationship between pH and pOH. So pOH goes to pH. Then from pH, we can find the hydrogen concentration because we know that those two things are connected to each other. Now, if you follow the equation process here, you're going to see what we do is we're going to take our pH is 14 minus pOH. That's going to be 14 minus 10.24. It's going to get us 3.76. Now, here's the interesting thing. We've always done pH as negative log of hydrogen. Well, what we're going to have to do is rearrange this to solve for hydrogen. So the first step is get rid of the negative sign by multiplying or dividing -1 on both sides. Gives us log of the hydrogen ion is equal to the negative 3.76 value. Now we've got to do an anti-log. Basically, we'll exponentiate this. We're going to take our negative 3.76 and we're going to take both sides and raise them by 10 to a power. So let me show you on my calculator how this is going to look. We had our 14 minus 10.24, and that got us into our 3.76 value. Now what we'll do is take the negative of that 3.76, and we're going to hit this 10 raised to the x key. So remember that this is how you do the opposite of a base 10 log is 10 to the x. So this gets me 1.7378 and a bunch of other digits. You're going to see, rounding that off, we get 1.7 times 10 to that -4th power. So final stage in this is just check to make sure you have a reasonable answer. Since we're going to have a value between pH 3 and 4, that's the goal, then we know that we should have a hydrogen concentration around 10 to the -3rd or 10 to the -4th power. We found we've got 1.7 times 10 to the -4th. That's going to be reasonable. So time to go ahead and get into our practice that should connect in. The multiple choice practice problem, you always want to think about it as though you're on the AP exam. So we don't have a calculator here. We just have to understand the concepts that underlie whatever the question's asking. So our scenario is that we know a pH of 10.53, and it's asking which of these statements below are true. So the first question being asked is, the solution is acidic. We can do a quick test because we remember that pH, if the pH is going to be less than 7, that is acidic. If the pH is greater than 7, it tells us that this is basic. And if we had a pH that is equal to 7, we know that this is a neutral solution. So considering a pOH of 10.53, we know that 14 is pH plus pOH. Do a quick little mental math on that. 14 minus 10.5-ish is going to give us a number that is definitely less than 7. And it doesn't matter what that number is, right? We know that 14 minus 10 is 4. It's going to be less than 7. Since it's less than 7, we can conclude this is acidic. That's a true statement for part I. Second thing, the pH of the solution is 14 minus 10.53. Well, we've already established, well, that is how you do it, is 14 minus the pOH is the pH. That one is also true. Lastly, for the solution, hydroxide ion concentration would be 10 to the negative 10.53. If you recall, you're always going to take 10 raised to the negative power, in this case pOH, in order to get the ion concentration. And that's exactly what they've done in terms of their expression. So all three of these statements make sense. We didn't use a calculator. We just used our logic in this, right? E, all three statements are true would be what we select. Now in practice exercise 2, we're going to be given a value. we know a pOH of 4.82 is the starting condition when we have an antacid tablet dissolving. We are trying to determine what the hydrogen ion concentration is. So here's our plan of action. What I want to do is take the given pOH and convert that into a pH. Once I've got a pH value, then I can convert into the hydrogen ion concentration like we practiced. So as I do this, we're going to exponentiate 10 raised to the negative pOH. So 10 to the negative 4.82. Throw this in here, 4.82 negative, use that 10 to the power key right there, and I get 1.513, and we'll say 6 around that, times 10 to the negative 5. Now, notice that I'm not rounding this right now. I'm giving it a lot of digits, and that's because we don't want to have a rounding error as we approach our final answer. We don't do our real rounding up until the end. So this was our pH value that we derive from the pOH. No, that's not. Oh, hey, guess what? I didn't follow the method that I had planned. What I just did there is I went from pOH to the hydroxide concentration. But you know what? That'll work too, actually. So why not? We're going to call an audible. We'll say that's hydroxide concentration. Now that I know the hydroxide concentration, I can use that to find the hydrogen concentration. Recall that 1 times 10 to the negative 14th, that's the Kw value there, right? So Kw, if I divide away the hydroxide concentration, what that'll do for me is give the hydrogen that I'm looking for. So doing that here, we're going to say it's 1 times 10 to the negative 14. Divide away the 1.5136 times 10 to the negative 5 power, and we get 6.60 times 10 to the negative 10. I'll actually have to take the time to round that off, and it would be 6.6, not 60. 2 sig figs here because the pOH value had 2 sig figs with the 8 and the 2 initially. So hope that helps, and we will keep on going.